If you take a look at your memory card, the last set of functions for which we do not have derivative rules for, those would be the logarithms, which appropriately enough is what this lesson is all about. Being able to calculate the derivative of logarithmic functions. We've got natural log, which is what's being graphed over here, of course, or the log base, whatever it is that you want, as long as it's a positive integer that's not 1. Yes, okay. So let's start by warming up a little bit, refreshing our knowledge about some various properties of logarithms. Number 1, we want to use some properties of logarithms to expand out the natural log of, now that's not cube root, that's 3 times the square root of x divided by 5 times y to the third. Here, let's try this. Okay, so remember that when I'm taking the log of a quotient, I can break that up as the difference between two logs. The reason why is because a logarithm is an exponent, and whenever you are dividing with like bases, you subtract the exponents. So this is equal to the natural log of 3 times the square root of x plus, except for minus, the natural log of 5y cubed. Okay, so far so good. Now, moving from left to right, notice that I've got myself a product right here, and I can break that up as addition. And again, it's because logarithms are exponents, and when you're multiplying with like bases, you're supposed to add the exponents. So this one is equal to the natural log of 3 plus the natural log of the square root of x. All right, now we're going to do the same kind of thing over here. I've got 5 times y to the third power, so I can break that up also as an addition, as a sum. But make sure that we distribute our negative sign here, so I'll put parentheses, natural log of 5 plus the natural log of y cubed. All right, I'm quickly running out of some space here, so I'm just going to, I'll bring all of this stuff down, shall I? Okay, that's good. All right, and let's keep going because I think that we can still do some more stuff. Like, for example, I'm going to rewrite this as an exponent because whenever you are taking a power to a power, you're supposed to multiply those exponents. So if I look over here at this natural log of y to the third, I can take this third power right out here and multiply it. So I'll do the same thing with this x squared, square root of x, thinking of it as x to the 1/2 power. And that 1/2 will come out on the outside of this. Okay, so we have the natural log of 3 plus 1/2 the natural log of x minus the natural log of 5. And then I'll bring this 3 out to the front as well and distribute the negative sign through this, negative 3 natural log of y. All right, so that was one of the things that you did with logarithms in either pre-cal or in algebra. Pretty handy. You'll see that it will be handy for us whenever we're taking the derivative because, let's just give you a preview here. If I had to take the derivative of this, it'd be much easier to take the derivative after it's expanded than when it's condensed like this. Speaking of being condensed, that's what we want to do over here on number 2. Use properties of logarithms to condense. We're going in the opposite order here. Natural log 8 plus 2 natural log of x minus the natural log of y. So I'm going to move this thing left to right. It's kind of PEMDAS. I'm going to take this 2 and I'm going to bring it out into this x as an exponent. Natural log of 8 plus natural log of x squared and then minus the natural log of y. Okay, and again, moving left to right here. Addition comes before subtraction just simply because I'm moving from left to right. So I've got to do this part first. And the addition of these two things will condense down to a product. Natural log of 8x squared minus the natural log of y. And then finally, there's one more thing left to do. I have the difference between two logs. That's going to be the log of the quotient of those two factors. So the natural log 8x squared over y. There we have it. All right, once again, you might be wondering, why we're doing all of this. It's just because that whenever I'm taking some sort of derivatives of these logarithms, sometimes using these properties are going to help us really simplify our problem. Okay, so the reason why these products work is because they're based on properties of exponents, because logarithms are exponents. We got the product property of logarithms. Let A is the base, as you can see here. M and N be positive real numbers, with A not being equal to 1. You can't have 1 as your base, can't have a negative number for your base. And remember, the domain for logarithms is always greater than 0. Not equal to 0, but always greater than 0. That's why it says positive real numbers. Okay. All right, and then we have the log base A of the product is supposed to be equal to log base A of M plus log base A of N. The reason why, of course, is because it's based on property of exponents. Where I'm multiplying with like bases, I'm just supposed to add the two exponents. Then I have one for quotients, quotient property of logarithms. Log base A of M divided by N, that's going to turn into a difference of these two logs because of the quotient property of exponents. A to the M divided by A to the N, I have like bases, I subtract the two exponents. And then one final property, and that's the power property. Power property of logarithms allows me to take this N exponent and bring it out to the front and multiply it times the log base A of N. And it is also based on a property. It's the power property of exponents. A to the M raised to the N power, you multiply those two exponents.